ever say like Monday it's like A, Tuesday's B, and then like keep it the same, and then Friday
should be the swing
like,
day.
everybody's the same, but it's like you go to all of the classes in one day.
Sounds. Oh, I get what you're saying, like a skinny day.
Yeah, like a regular day.
Oh, that's
I like it.
Like 45 minutes the same.
I like it. They people have presented that. Right. Okay. All right. Let's look at 5.1, and this shouldn't take us that long. You can't see it. So. All right. Okay, the first thing we're going to do is go over some definitions. Talk about what a polynomial is, or we classify it. Does anybody know what the prefix poly means?
Multiple.
Poly is many or multiple. It's many. A polynomial is a monomial. You might know what the prefix mono means? Good. It's a monomial, or the sum of many monomials. And some examples of polynomial. So many things that you've looked at in math are polynomials. You've just never been told that. Even in kindergarten and first grade, when you say 2 + 2, that's a polynomial. There you go. So a monomial can look like this, where you just have one term put together. This is one term. Anything separated by addition or subtraction is, of course, two terms. So that's what makes it multiple terms. So if you just have one chunk of stuff all multiplied together, that's one term. So this would be an example of a monomial. If you have 3x squared plus 2y, and of course, they're all still polynomials. They just classify them differently. So it is a polynomial, but more specifically, how many terms does this have? 2. So this is a binomial. But they're all, of course, under the umbrella term of polynomial. It can be one term, it can be 2 terms, or the sum of however many. And the reason that they say sum is because if you had something like this, 3x squared minus 4, well, that's also the same thing as saying 3x squared plus -4. So that's why they just say sum. What? What'd y'all say? Okay. But don't worry about, try not to think too much about that, rewriting it, because you'll never see anybody rewrite 3x squared minus 4 as 3x squared plus -4. Okay, I'm not going to make you write the definition of monomial, but what any of these terms, the definition says it is the product of a real number and variable, or it can just be a real number by itself, so on. So monomial is just one term. All right, how you get your degree, and this is very important. You're going to see the degree used a lot in this chapter as far as graphing polynomials. You're going to see degree again when you get into pre-cal. So the degree of a polynomial is the highest or greatest exponent of its terms. The highest exponent of its terms. You're going to see in a minute, we're going to practice putting a polynomial in what's called standard form, where they line up the exponents from highest to lowest. And that, like in standard form, when you're graphing a line, ax plus by equals c, in standard form polynomials, where you just line up the exponents.
I don't even get why it matters, but where do I put it? You know, like,
I know,
what's the
it-
difference? Takes you 2 more seconds to read it, I'm sorry.
It really don't. I mean, it's like, honestly, as you progress in math, I mean, you'll be able to easily see, okay, my highest degree is, or my highest term is this one because it has the highest exponent. All right, must be in standard form, and that's just simply where you arrange your terms in descending order. Okay, so an example of that. Okay, this is an example of a polynomial. You've got terms added or subtracted together. So if you want to rewrite this in standard form, notice that the term, your highest term is here, positive 4x cubed. It's got the highest exponent. So that, of course, goes first. And then tell me what comes next. Good, minus 2x squared. What comes next? Good, plus x, and then minus 5. Constants always go at the end. This is also known as your leading term. That's your leading term in that polynomial. But anyway, now that it is in order from highest to lowest, or descending order, your degree of this polynomial is 3, which you can see that. You don't have to put that. That's what I'm saying. Like, y'all are like, what's the point in us putting it in order? You can easily look at your polynomial and say, okay, my degree, the highest exponent is 3. So degree is 3. But you will be required to put it in standard form and solve your problems on Math Excel. Okay, you don't have to write this one down unless you just want to. What's your highest, or what is your degree of this polynomial? There you go. Okay, now that let me go back up here really quick. This was saying how many terms did we have in our polynomial, and then another thing you can look at is what is your degree of your polynomial. In 5.1, they have you classify polynomials by its degree and number of terms. Okay, what all right, all throughout math, ever since you started dealing with x and x squared and x to the third, what did you call an expression that just had x? Like if I ask you to graph y equals 2x plus 3, what will that graph look like? Okay, it would be a line. So if your exponent of x okay, this is how you classify it by degree. So if my degree of x is 1, or my highest exponent is 1, then it is linear. So if you just see 3x plus 5, you're going to say that is a linear polynomial. What if your exponent is 2? Highest exponent is 2. We studied these in chapter 4. Good, quadratic.
I thought that meant 4.
I know, I wish they would just change that, because everybody, quad 4, you've been taught all through elementary school, quad 4, and then when you get to, upper level math, no, degree 2 means quadratic. Okay, if you have x to the 3rd, and that's your highest exponent. Good, cubic. Hey, you're not wrong. I know. Okay, 4. Here you go.
Wait, what?
Quartic. Quartic. Okay, people that have 5 kids all at one time, what do they call those? There you go. Quintic. Quintic. Okay, when you get past 5, if it is 6 or higher, I don't know why they stop at 6. If it's 6 or higher, you would just say that is a polynomial of degree 6, polynomial of degree 7, polynomial of degree 8. So yeah, I'm going to abbreviate here. Polynomial of degree 6. That's what you would say. Now, there is one more that we haven't listed. What if you don't even have a variable? What if you just have 7 plus root 2? That would be a polynomial of degree what? If you don't even have a variable in there, 0. So if you have a degree 0, that's when you're not even going to see a variable in your polynomial at all. So it would be a constant, because it's just going to be a number. So the number 5 is a polynomial, or it's a constant polynomial with degree 0. It's kind of weird to think about it like that. Okay, how you classify them by the number of terms. We talked about this a little bit as we went through some problems encountering polynomials. Number of terms. If you have one term, like we had 3x squared, that's just one term. What do we call that? Good. So one term, it is a monomial. Okay, if you have 2 terms, what is that called? Binomial. 3 terms? Trinomial. Remember us factoring binomials and trinomials in chapter 4? You guys love that so much. Okay, they stop. I know. They stop after.
They should have stopped that way with the degrees.
I know. Whoa, don't write that. It's not degree. Sorry. I was thinking about them stopping their different, like you were. Polynomial of 4 terms is what you would say. Polynomial of 5 terms. Polynomial of 6 terms. I don't know why they couldn't just say like quadnomial or something like that. Quintinomial. I guess I can probably see why like 6 would be kind of hard. What'd you say? Oh, yeah. No, I cannot. Nope.
I know
Octomom.
It blows my mind every time. Because it's not even just a twin, just 4 separate children. And that would be a lot of money. Better be married and great.
Yeah.
I mean, would they be Hey, when you have 8 kids, you can really get a lot of corn, you know? Yeah. Once they get older, you can just like need them to work.
All right. We're going to practice writing in standard form, classifying by degree and number of terms. And number 1, we have negative 16x. The first thing you need to do in these problems is make sure that you can't combine any like terms or nothing needs to be done before you classify it by degree and number of terms. So as you'll notice, go through and see if you have any like terms to combine, and you do at the end. So if we write this in standard form, tell me what goes first. Good. Negative 32x cubed. What comes next? Plus x squared. Good. Minus 16x. And you can just mark through them if you want to, like as you go. And then, of course, constants go at the end. So what do you put here? You can go ahead and combine it. Yeah. Hey, you had it right though. You would put 10 plus negative 5, but go ahead and simplify it. So that becomes plus 5. Okay, that's only one part of what they ask you to do. Now we have to classify it by degree and number of terms. Your degree is what?
3.
Good. So it is a, what was degree 3? Good. Now classify it by number of terms. It's got 1, 2, 3, 4. I'll go ahead and tell you, look, how many plus or minus signs do you have?
3.
You always have one more than the number of plus and minus signs. So I've got 3 plus and minus signs. It's got 4 terms. Does that make sense? So it's polynomial. It's a cubic polynomial of 4 terms.
Also, why is that
You've got 1 term here, 1 here, 1 here, 1 here. No, it wasn't. Don't say that. But going back to your question, when you say why is it important? You'll see polynomials a lot in pre-cal and calculus. So knowing, like, it'll help you be able to manipulate them quicker if you know general things about them like that. Like as far as graphing them, solving them, which we're going to graph them and solve polynomials. Plus, knowing this degree, if this were set equal to something and I ask you to solve for all the values of x, your degree tells you how many solutions that you'll have. So you'll have 3 solutions. It will also tell you how many times that it might possibly cross the x-axis when you graph it. So, all right. Plus, positive 5, the number at the end in a polynomial is where it crosses the y-axis. So this would be where it would cross. If you graph this, it would cross at 5 on the y. So anyway, all right. Number 2. I don't know if that helps you at all, but
A little bit, I guess.
okay, 7y to the third minus 10y to the third plus y to the third. Can you simplify that before you do anything else? Yes, they're all like terms, so combine them. What do you get?
8y, negative 8y, no, negative 2y third.
Good. 7 minus 10, this will give you negative 3y cubed. Plus one more will give you negative 2y cubed. So here it is in standard form. It's only how many terms? What's its degree? So it is a cubic. There you go, cubic monomial. Yeah.
Do you actually like?
Yes, I do.
Wow. Well, I have a.
Remind me after we finish, I'll tell you how I became a math teacher because I changed my major about 4 times.
Like I enjoy doing that. Yeah, math. Are you serious?
There you go. Okay. All right, this is right. Okay, you're gonna write this in polynomial. Write it in standard form, but you first have to multiply these together before you can even figure out what your polynomial should look like. So you have to distribute or do the FOIL. So make sure you multiply 2a to both a and negative 1. So you get 2a squared, and then what's my next term? Good, minus 2a. Then you have to make sure that you distribute negative 5 to a and negative 1. So now you have negative 5a or minus 5a, what? Plus 5. Simplify again if you can. Good, you can combine those. Every time you do FOIL, more than likely you need to combine outer, inner, or middle terms. So this is minus 7a plus 5. Okay, that will not go any further. What's your degree? Degree is 2, so it is a
Quadratic trinomial.
good quadratic trinomial.
I did that all of my friends. It was just like you were echo.
Let me check your.
Also, are we supposed to get like report cards
Tomorrow.
My mom asked me if I had one. My mom asked me if I got mine on Friday, which mom, I wasn't even at school. I can't get it if I'm not. Well, my
They
mom was like,
really,
"You have your report
I think
card."
overall in
No.
the district overall should have extended like report cards and should have let parents know that, because like Grissom, we had to ask for an extension like individually. Like I know districts still sent them out, I think last week, but I'm like, with a cyber attack and we can't even get on the computer, like how do you expect us to be able to get grades finished in time? But I think, but anyway, they go out tomorrow because we finally got grades in today. Let me make sure that I didn't assign.
I feel like we did something like this before.
You probably, more than likely, you looked at this in algebra 1.
I don't remember like anything from that class, but I had Miss Carter. You remember her? Yes, I do.
Miss Carter, who's in the meeting?
Huh?
Who's in the meeting?
Me?
There was one of the kids in our class that like she taught their parents. Yeah,
Okay.
she taught my older brother, Miss Gable, my elementary PE teacher, was also my dad's she went my class too. Yeah, I think she was there like the whole time and found this. I don't know if it's her. Oh, really? It could be very wrong. Like, really, I remember in my head, and he said like, she taught his mom. Or like she taught Mr. Miller. Really? Yes. Do you know Coach Roden, man? Yes. He went to this. Why did he leave? Because they paid him. But you have to actually teach over there, you know? I know. That was like honestly, I didn't. Yeah, the only thing I learned was hash browns too. Yes. That was it. Hatch brown. I didn't even know her real name because that's what we called her. It was like hatch or something. Something like that. It sounded like hash browns too. That's what we called it. It was some girl. I remember seeing pictures. My dad had oh, I have like rugby pictures of my dad. Rugby is a very violent sport. I know. It's a scary sport.
Yes.
My mom used to play softball. She said, I can play softball. I played softball. I was on the all-star team all 3 years I played. Oh, nice. Yeah. I should have kept going, but I hated it. Do you like soccer at least? No. I used to play soccer when I was like 2, but I quit because of the ball. Wait, is this about my behavior? Why does it take life to like life and awesome? Oh my god. Actually do that.
What?
I just have a pencil. I got a set of $3. No, let's hear about real. I'm say for $1. I gotta stick with the $1.
I don't have that money to get the stickers, you know? Is that the only thing we left up?
I'm sorry, what?
Yeah.
You know, like they tore down the whole shopping center.
Oh, yeah, the stickers is the only thing.
It's really awkward getting
It's
it.
not like
It
that.
is.
It is, because like you have to go through the empty parking lot.
And I saw this guy just sitting in the middle of, like, where they get public, just sitting in the parking lot.
They've taken a long time to start on that. Like,
All right, you don't have to write this next part down.
And now it's all cleaned up. So that takes a while.
Okay. Okay, tell me what a coefficient is before we get to discussing this. It is definitely a number. It's the number in front of your variable. There you go. There you go. So the last thing we're going to talk about in 5.1, and you're going to use this in 5.2 to graph polynomials. Yay, fun times. Is the in behavior, and all in behavior is what is a graph doing on the left side? What is it doing on the right side? Is your graph going to go up? And you don't have to write this down either. For a quadratic, a parabola, your graph goes up on the left side, it goes up on the right side. Or of course it can be flipped down and it can go down on the left and down on the right. That's what it means by in behavior.
This is what it asked me on that homework, but I had no clue. I was just guessing.
Now, this is for, of course, a quadratic. This is what the graph of, that is for x squared. This is what the graph of y equals x cubed looks like. So notice that the graph would go down on the left side, it would go up on the right side. So that's all you're going to talk about when you give in behavior. All right, and this is how you determine what your in behavior is. If it's going up, down on left, up, down on right. You use your degree of your polynomial that we just looked at and practiced finding, and the leading term or the coefficient. So you're going to find, you have to make sure your polynomial is in standard form, or at least find your highest degree, then look at the number in front of it. Is the number in front of it positive or negative? So the two things that you're focused on, degree of your polynomial and what is the sign of the coefficient. Use degree of polynomial and leading term sign to determine the in behavior of your graph. This is known as the leading coefficient test, is what they call it. Okay, we're going to look at what your graph looks like if it's an even degree. And what your graph will look like if it's odd degree. If your degree of your graph is 2, 4, 6, if it is an even number, these graphs have the same end behavior. They're either going to go up, up, or down, down. Same end behavior. Just like the parabola that I know you're used to or familiar with. Same in behavior. So if even degree polynomials have the same in behavior, then odd degree polynomials would have what type of in behavior? Good. They have opposite in behavior. So it's either going to go up on the left, down right, or vice versa. Down left, up right. Odd, opposite, even, same, even, same, even, same, odd, opposite, even, same, odd, opposite. Okay, if your leading coefficient is positive, so if I have a positive number out front. So for example, I'll do the basic graph that you know. All right, we'll say example y equals x squared. X squared, I've got, what's my coefficient in front of x? Good, positive 1. It's an even degree. You know that that graph looks like this. So what is your in behavior when your degree is even and you have a positive coefficient? What will your graph do on the left side and the right side? Good. So you would say it goes up on the left side and up on the right side. Or you can say up, up, it doesn't matter. Up and up. So even degree, positive, up, up. Okay, what about if your leading coefficient is negative? What do you think your graph, it's even degree. Let's say I've got y equals negative x squared.
Down.
Good. It's going to flip your graph. So then it's going to go down on the left side and it will be down on the right side. Okay, does that part make a little bit more sense now that we've gone over it? Okay, good deal. All right, let's look at what happens when your degree is odd and you have a positive coefficient. So an example would be y equals positive x cubed. The graph of y equals positive x cubed looks like this. So what is it doing on the left side? Good. It's going down on the left side and it's going up on the right side. Okay, odd degree, it's negative. So we'll say y equals negative x cubed. All it's going to do is flip that graph. It flips it over the x-axis. So this part now moves up here, and this is what negative x cubed will look like. So what is it doing on the left and right side? Reverses that behavior. Sure. There's no one on class anymore. Yes. Okay. I think she's got a skill. I don't know if she's got a skill at this time, but I know she's her math. You're welcome. Okay, do y'all have any questions about in behavior? All right. Okay, we're going to use the leading term or leading coefficient test, and you're just going to tell me what the end behavior of the graph would look like. Okay, y equals 4 minus 5x. What's your degree here? Good, your degree is 1, so it's got an odd degree. Good, and it is negative. Yes, you only look at the number in front of your term. Yeah, your number in front of x. Okay, so what will this graph do on the left side, on the right side? Good, it's going to go up on the left, down on the right. And you can either draw the arrows or you can write it out. I don't care. All right, number 2. Don't freak out when I write this up. What'd you say? Well, usually if I write out something like that, people are like, oh my God.
Well, it does look pretty bad.
Exactly. All right. In number 2, now, notice that this expression is in factored form or non-multiplied, like it hasn't been multiplied out yet. You don't have to do that. That would be awful to have to do that. How you can easily get your degree, if it's going to be odd or even, and get it signed, is you use the first term in each factor. For example, like, what is your degree of just this? Good. My degree here would be 1. What's my degree in the middle? It's also 1. What about the degree at the end? It's also 1. So to get your degree overall, if you added those up, your degree would be what? 3. And also think about it like this. If I take x, which is my leading term here, x is my leading term here, 2x is my leading term, and I multiply all those 3 things together, x times 2x, you'll get what? You would get 2x cubed. So you can also do it that way. Take your leading term in each part and multiply it together. 2x cubed, is it positive or negative? Good. It's positive. And another way you can look at that, this is positive, positive, positive. So what will your end behavior be? Yeah, down, up. Okay, how do y'all feel about that? What? Elena, do you get how we got 3? Okay. You understand how we got positive? It's because like x is your leading term here. X, if you take the first term or your leading term in each individual part and you multiply that together, you would get 2x cubed, and it's positive. So that's how we got positive. And then this polynomial would have an odd degree of 3. It's positive. So if you go back to what you just wrote down, positive and odd degree would be going down on the left. Like this graph would go down on the left side, it have some crazy behavior, and then it would go up on the right side. Y'all can't see that, sorry. Anyway, like this graph would look like that. It'd go down on the left, it'd have some weird behavior in the middle, and it would go up eventually on the right side. I get you. It's just kind of, you'll get it. You'll get the hang of it. Yeah, it is. Yeah, you definitely have to look back at that chart. Okay, so in this last problem that we're going to look at, this is one term here. So this is my first term. What's my term in this part? Or leading term in this part? What'd you say? Like leading term is simply, what's your highest degree in that part? Good. Your degree is 1, so that means x to the first is your leading term there. And your degree is 1 here, so that means x is my leading term in that part. So take all of your leading terms, all of your terms there, and multiply them together. So negative 2x times x gives you what? Oh, wait, I forgot. Look at this one at the end. So sorry. Check this out. This one is what? Yeah, so we got to square that. So make sure if you have an exponent outside of that individual factor that you raise it to that power. Okay, now multiply this together and you get negative 2x what? Negative 2x to the 4. So this would be my leading term overall. So we're going to use this. My degree is what? Good. It will go down, down. Your degree is 4. Your leading number is negative. So my end behavior, even degree, they're either going to go down, down, or up, up. If it's negative, it goes down, down. It is. And this is the first time really you guys have ever seen anything like that. So when you get in the pre-cal next year and you see this again, because that's what we do in chapter 2 is we graph polynomials. And they're like, okay, yeah, I know that. Okay, yeah, it's better this time around. Yeah, we'll see. Okay. You will. Don't say that. You will. You'll be fine. Stop share. Stop recording. I don't know why. Like it. I wish I was still that skinny though.